quickly about how probably won't be able to finish, but I just want to show you the code, and then you can read the code, calculate, or you come up with other things. I'm actually excited to see if anybody comes up with something more efficient than the one that I did. But in short, we're trying to figure out, based on the definition that we introduced and how to compute those quantities, how can we work out the ACS sample, the synthetic ACS sample for the identification disclosure. Okay? So bringing it back to the sample, we have 9 variables here. And you will see that in the synthetic data that I provided to you, 4 of them are synthesized, okay? And then we assume that the intruder knows the first 3 variables, the sex, race, and marital status. And you notice that the sex, race, marital status, they're not synthesized, okay? We deliberately do this in a sense that we're assuming the intruder knows variables are not synthesized, okay? And then, but in the synthetic data, they're synthesized variables, so there's still like their variability in terms of how much the people will be able to get. Okay. All right. So the data sets that I uploaded, there are 2. The ACS data org, that's the original one. The ACS data synth, that's the one synthetic ACS app. The 4 variables is language, place of birth, I think, disability status, and health coverage status. Okay. M equals to 1 for illustration purposes. You can do that for multiple later. And the known variables is sex, race, and marital status. And the goal is to use this information about sex, race, and marital status to identify records in the synthetic data, and then obtain the 3 summaries that we talked about. So first of all, we load the 3 data of the 2 data sets, the original and the synthetic. All right. Okay. The step 1 is calculate the key quantities. What I mean by key quantity is the CI, the FI, the KI, and TI. Okay. So I don't know how much I can talk through them in class. But pretty much, I'm using the definition that we introduced and then doing the calculation through a function. Okay? So there are 2 pages of this slide, 2 slides of this function just because, well, I couldn't get the font even smaller to put everything in one. But in short, you can see that I'm trying to count based on the original, based on the known variables and the synthesized variables, I'm counting how many observations share exactly the same thing that I have. Okay, so that's how I get this match. Okay. And then I'm looking at, and then I'm checking how many observations are there for my CI, right? C vector I. I'm counting how many observations are sharing the same combination. And then I will set CI to be 0. If not, and then TI is, I'm using this isElement method, function named R, to check if the original data is among the ones that I matched. So this is some key from the code. And then the other thing is, well, then I'm able to define my K and F. We know how we define it. K equals to 1 if C times T is 1. Okay. F equals to 1 if C times 1 minus T equals to 1. Okay. So that's how I get my K vector and F vector. In the end, I get my S. That is counting how many CIs are 1. Okay, so then I get my S. So that should be all good. And then I run this on my original data. So notice that I write a known variables and synthesis variables into those 2 objects here, and then pass them into the function to do the calculation. Okay? I mean, you can hard code everything if you're just playing with it. But this is probably a better way, since later you might want to change the known variables and the synth variables accordingly. Okay, so this will be something good to, I think, use in your synthesis model as well, if you can write your functions in a more efficient way. And then the second step here is calculate the 3 summary measures. So again, going back to the definition of the TI over CI, sum them up, right? KI over N, sum them up, and then FI over S, sum them up. So this one is probably a smaller chunk, and make sure that you check, set all of the, when you have CI equals to 0, set that to be 0. Set that TI over CI to be 0. We talked about that just now. Okay. All right, so just want to show you the results we have on this data set. I have 41. 0.0005 for the true match rate, 41.4-ish for the expected match risk, and then 97%-ish for the false match rate. Okay, so Did anybody try to do this before I post the slides, or did you get the same numbers?
Well, so I, when I did the calculation,
Yeah.
I didn't I assumed that just the unique value was already in. So I got like 57 for the first
Oh,
one.
but the other two will be the same, right?
Yeah, my second one was 4 to the negative 4, or like 4e.
Oh, okay.
So I don't know if like the way I was calculating
Yeah, okay.
because I assumed that from the first one, and the
Right,
third one
maybe,
was 0
maybe.
because
Yeah.
the true one was always.
I see, yeah. So, right, so good, so maybe just change that. So, the reason why I'm asked is, well, first of all, check if you did the work, but also, there's no like, uncertainty in this, any kind of calculation here, okay? Everything is, I mean, if I give you the exact same data, we use the exact same data if we all follow the definition and calculation closely, and if you write your other ways of calculating it, they should be the same. So that's what we need. And so that's why I was asking, but feel free to borrow what I wrote, and I had a little bit of discussion over here, but let's not worry about it since we're running out of time. But I do want you to take notes of, well, what if you, it's a good practice to write functions, okay, to calculate various quantities. And if you have more than one synthetic data, you can change all of the vectors in the function that I've provided to be matrices, okay? And then you can also just create like S. S is a scalar count of how many unique matches are there. So in one synthetic data as a scalar, but then in multiple synthetic data, you can just make it as a vector and then loop it through in your function, okay? So you can build up your own function of calculating the identification risk from the basics that I have, and I will leave that to you to do it, and then you will be able to use this set of stuff for any kind of identification, disclosure, risk evaluation for categorical data. For numerical, well, think about it. I mean, 2 weeks of spring break to think about if you want, and because I mentioned this mostly because as we noticed, many of you are dealing with synthetic data with continuous variables, right? So when you evaluate the risk, well, what I presented won't be directly applicable because you have continuous variables to think about the risk. Okay. All right. Okay. I'm gonna end here. Sorry for running a little bit late, and I will post the slides. Yeah, I won't. I mean, I actually didn't record any of the model presentations. So I'll just have the other stuff that we talked about. And upload it later if you want to watch.